Our learning goal for this lesson is to use the quadratic formula to solve solutions of quadratic equations in exact form, which means not using any decimals. To do that, we need to use radicals. So this first video is just a little bit of background on how radicals work, and then in the second video, we'll apply them to quadratic formula. So a radical is basically a number underneath a square root. In order of operations, you would do roots the same as exponents. Also, in the order of operations, everything under the square root is considered to be in brackets. That is, all operations under the root sign must be carried out before the square root is applied. First, we will do some quick evaluating of some radicals. The first one is the square root of 16. I know it is the square root, meaning that with the root, the square root is the most common root that we take, so we don't write the 2. So you assume that it's the square root unless it's stated otherwise, like in the next example, where it is the cube root. So to take the square root of 16, we have to find a number that when you multiply it by itself gives you 16, and that answer is 4. To take the cube root of 27, you need to take a number and multiply by itself 3 times to give you 27. So that is 3 times 3 times 3. Because 3 times 3 is 9, times 3 is 27. Make sure you know where the cube root is on your calculator. The next one is the square root of -4. This is not possible because we cannot square root a negative number. In the next example, we want to take the cube root of -8. This is possible, as -2 times -2 is positive, times -2 is -8. So our answer is -2. Basically, if the root is odd, you can take the odd root of a negative number. When the root is even, you cannot take the even root of a negative number. The next example, we have the square root of 16 plus 9. And remember, we already said that you treat underneath the radical as if it was in brackets. So following BEDMAS, we're going to simplify in the brackets first. So 16 plus 9 is 25. The square root of 25 is 5. And the next one, we can take the square root of 16 to get 4, the square root of 9 to get 3, and then multiply those together to get 12. We are now going to simplify radicals. This means that we want to find an equivalent expression for each radical, not in decimal form. So the method of doing this is to take the number underneath the square root and write it as the product of 2 numbers, where one of the numbers is a square root number that's as large as possible. So for instance, when I want to take the square root of 48 and simplify it, I know that 4, which is a square number, goes into 48, but 16 is larger, so I want to put that into 48. So I'm going to write the square root of 48 as the square root of 16 times 3. And then the rules of radicals say I can separate the 16 and the 3 under its own square root sign. And now I can take the square root of 16, which is 4. As I cannot take the square root of 3, I just leave it as the square root of 3. You should always inspect what's left underneath the square root, the radical, just to see if you could break that down even further. I cannot here. And the only other thing just to make note is when I write the 2 square roots next to each other, really what you're doing is multiplying. And same with here, 4 times root 3. In the next question, I want to take the negative of the square root of 128. So I'm going to break that into the square root of 64 times 2, which means I'm taking the square root of 64 times the square root of 2. The square root of 64 is 8. So my answer is -8 times the square root of 2. We will just do 2 more. In this one, I want to simplify 3 times the square root of 50. So that's 3 times the square root of 25 times 2, which means 3 times the square root of 25 times the square root of 2. I can take the square root of 25, which is 5. I cannot take the square root of 2, so I leave it as root 2. And now I can simplify by multiplying the 2 times the 5, which is 15 times root 2. So 15 root 2 is my simplified mixed radical. Mixed because it has this whole number and then the number under the radical. In the last example, I want to simplify 2 times root 45. So again, I'm going to split the root of 45 to root 9 times 5. And again, I can split each of those up separately. Root 9 times root 5. I can evaluate square root of 9, which is 3 times root 5. And now I'm going to multiply the 2 times 3 together to get 6. So my answer is 6 root 5. We are now going to quickly look at adding and subtracting radicals. So when you're adding and subtracting radicals, it is very similar to adding and subtracting polynomials. You must have like terms, or in this case, the radicals must be the same. So here we see 2 times root 3 plus 5 times root 3. The radicals are the same. So now I just say I have 2 root 3's and 5 root 3's. So altogether, I have 7 root 3. Just like if you were adding 2x plus 5x, you would have 7x. Here, the base x is the same. So here, the root 3's are the same. In the next example, I have 4 times root 5 plus 3 times root 7. Here, the radicals are not the same. So this example cannot be simplified further. So it is already finished. In question 3, I have 5 times root 3 plus 2 times root 75. Root 3 and root 75 are not the same. However, I can simplify the root 75. So I have 5 root 3 plus 2 times root 25 times root 3. I just skip the step of writing it all under one square root. And now I'll just simplify the second term further. So that's 2 times 5 times root 3. So that's 5 root 3 plus 10 root 3. And now I have a common radical of root 3, so I can add those together. So I have 15 times root 3. And in the last example, again, my radicals are not the same. I have root 16 and root 36, but I notice that I can evaluate both of those. So that's just 2 times 4, because the square root of 16 is 4, minus 5 times 6, as the square root of 36 is 6. So 2 times 4 is 8, 5 times 6 is 30, 8 take away 30 is negative 24. We are now going to do some examples of multiplying and dividing with radicals. We have already seen the rule for multiplying radicals when simplifying. And that says that when you are multiplying 2 numbers under a root, you can write each number under their own roots. And same with dividing. When you're dividing 2 numbers under one big root sign, you can split them up so they're each under their own root sign. So let's see this examples of these rules. So root 5 times root 5, you can write this under one square root. And you get the square root of 25. Which you can evaluate as 5. I would not expect you to write these steps. You should recognize that the square root of 5 times the square root of 5 is 5. In the second example, I have root 2 times 3 root 2. So it's good to remember that in front of the first root 2, there's a coefficient of 1. And what I'm going to do is multiply the 2 numbers in front of the square roots, and I'm going to multiply the 2 numbers underneath the square roots. So here I get 1 times 3 is 3, and root 2 times root 2 is root 4. My next step is to evaluate. The square root of 4 is 2, so then I take 3 times 2, which is 6. In the next example, I have 4 root 7 times 2 root 3. So again, I am going to multiply the numbers outside of the square roots. 4 times 2 is 8. And then I'm going to multiply the numbers underneath the square root. 7 times 3, which is just the square root of 21. So my answer is 8 times the square root of 21. And just inspect what's underneath the square root to see if you can simplify that further. I cannot because there's no square number that goes into 21. In the next example, I am dividing 3 root 5 by 6. So I can divide the numbers outside of the square root, so the 3 and the 6, and there is no square root in the denominator, so I can't divide anything into the root 5. So to evaluate this, it's just working with fractions. So I know that 3 goes into 3 once, 3 goes into 6 twice, so I am left with 1 square root 5 over 2. You do not need to write that 1 on the top. You can just leave it as square root of 5 over 2. And in the final example, I have the square root of 54 divided by 15. So to approach this one, I notice that the square root of 54 can be simplified to root 9 times root 6 divided by 15. I can take the square root of 9, which is 3. So 3 divided by 6 divided by 15. And then again, I can simplify the 3 and the 15. And then I know that 3 goes into 3 once, 3 goes into 15 5 times. So my numerator is 1 times root 6, which is root 6, and my denominator is 5.